We ended up with like 85.
Okay.
There are instructions. You just go to the US code and you want to install on the whatever you want.
Okay. So I hope you have all of that in now. Your code should look something like this. This is my solution from milestone 1. So you should have this write function where you were reading, I'm using scanf to do things and inserting values into the memory area. Now this new piece of code, we have those 4 new functions that we used that we're going to implement today, and your initialization and exit functions. All right. So our task in this first part is we're going to translate our array that we created in milestone 1 into a linked list, and we're going to support 2 operations: adding an element to the linked list and deleting values from the linked list. So let's see how we do that. First thing you want to do is these 2 files, and so let me show you all 3 of them. So these 3 files include files, add them to your project. So seekfile.h, version.h, and list.h. Okay. If you have questions, just stop me anytime and we'll go over. Our first task is we're going to switch our pointer array to a memory area of integers into a linked list. The way we do that is I'm going to take out my previous definition, and I'm going to define a static list head and call it head. So the list head macro allows you to define a list head, or the head of your list. And remember from our previous discussion that the head of the list has no data, right? The head of the list is empty, and the head arrow next, first one, is the one that actually contains the data. Okay, so after that, what are we going to do? We need to define the structure that is going to hold our linked list elements and the values in them. So to do that, we're going to define a structure. Let's call it array element, for example. In it, there's an integer, which is the value of the array, or the value of the element at that point in the array, and the linked list element that corresponds to it. And I will call it a list, linked list for linked list. Okay, so this structure is what's going to build up our linked list. This is what's going to comprise our linked list. So, questions so far? Okay, let's go to our initialization function. And now everything that has to do with allocating memory areas for our memory array and initializing those, we're just going to take that out. So anything that references your pointer to the integer array, just take all of that out. Same thing in the exit function. We were freeing our array. Then we have to take out that code, that piece of code as well. Okay. Next up is let's modify our write function so that it accepts 2 operations: add a number or delete a certain value. So instead of we were in the write handler before, we were using, I hope you were using scanf to get the 2 integers that we were passing, right? So we were passing integer and value, index and value, but now we're going to pass element or character and value. The first character is going to be either add or delete, so A or D. The second element is going to be whatever you want it to be. So the first one is going to be a character. Second one is going to be an integer. So, and we have to create a character to hold that in here. Okay. And then anything that had to do with our integer array from before, again, we're just going to take all of that out. So two operations that we must support: adding a number to the linked list and removing numbers from the linked list. So the first case we're going to handle is if the operation is an addition, or like adding to the end of the linked list. So what we have to do is we have to create an array element, and then we have to add it to the linked list. So to create an array element, we first declare a pointer struct array element star element in the right handler. Okay, so that's where you're using scanf and doing the actual addition to the before we were doing indexing, now we're just adding to the end of the linked list. So the first thing is I'm going to allocate room for that. So I'm going to kmalloc size of that element, and the flag has to be JFB curve. Okay. Now, normally you should be able to, you should do error checking. So if not element, return some kind of error value. But I'm not going to do that today just because we want to move things. The second thing I want to do is I'm going to set the value in that element to the value that was passed from the user, that I read from the user. So the user passed A5, for example. Here I'm going to just save 5. And the way you add things to the end of a linked list is we use list add tail, the function list add tail. That is implemented and provided to you by the kernel. The first parameter, now one thing you have to be very careful about list add tail. First parameter is the new element. Second parameter is the head of your list. It's a little bit counterintuitive. If you swap those two, you're going to break your program. So first parameter to list add tail is the new stuff. Second parameter is the head of the list. So the new stuff I want to add is element and then the list entry in that one. And the second one is going to be the head of my list. Okay. And that's as easy as it is to add something to the linked list. Second thing we want to do is we want to delete something from the list. So the semantics of, I'm just coming up with these semantics right now. Basically, if I tell you D5, so delete all elements in the linked list that have the value 5. Right, so search through the entire list, anything that matches 5, you're going to go ahead and delete that. So how we're going to do that is we will have to define, I'm going to define another temporary array element and call it TMP, and we'll see why we're going to need that in just a few seconds. So the way to iterate over a linked list is you use the macro list for each entry. Okay? So list for each entry is simply a for loop over your array or over your linked list. Starts from the head, goes down to the tail. Now, if we want to delete things from the linked list, we can't really mess with the indexing while we're iterating over the list, right? That happened in 230, I think, when you learned iterators, or in 220, you can't modify, excuse me, an iterator while you're looping through it, right? So the same thing happens here. So to avoid that, we're going to use list for each entry safe, which means that this for loop is safe against deleting things from the list. Okay, so first parameter is going to be the element that you're going to use as the iterator. Second one has to be the temporary iterator. That is something internal used by list for each entry safe. Then you're going to pass your head of the list. Last element is the name of the list entry in your structure. So if you look at our structure array element, we called the list head list. When I use list for each entry safe, oops, I have to use list in here. It's the name of the entry inside of that structure. All right, so now I can actually iterate over things. I can access the element and check if it's the same as the value. So if the element in that list has the same value as the value the user passed to me, then I can call a function called list delete or list del. In that one, you just pass the list entry that you want to delete, which is element arrow list. So now we have deleted the node from the linked list. Okay. Now the other thing we have to do when we delete something from a linked list, we have deleted the node, but the structure is still there. Okay, so you recall we delete the node, but the structure that contains that node is still there. So what we have to do, if we no longer need it, we have to k-free the element, so that we don't have any memory leaks. Questions? So that's all we have to do for the addition and deletion from the list. I'm just going to add an option here that sets. For me, I always return the return value, so I'm just going to set it to invalid. Yeah. Yeah. So that's a structure that contains a next and a previous. That's it, right? But the thing is, the nice thing about it is that you don't touch those. The kernel takes care of everything. You just reference that list, that node structure. Yeah.
Are we going to be able to take the starting code that you started this with and use that, or do we have to use our milestone starting code because if we miss the current milestone?
I can post the code that I have from here, so you can, if you messed up milestone 1, you could use the one I have. Okay. Questions? Okay, so now we have taken care of writing to our linked list. We have to figure out now how are we going to read our linked list, right? So recall, we used to do two things. We used to do echo to the procfs entry to write things, and we used to do cat from that procfs entry to do things, right? So now we're going to do something that's kind of similar to make sure that our cat works, okay? So we're going to switch. Let me just remove this guy because it's no longer needed. Okay. So before we had our read handler, and that read handler, we used the position or the offset in it to make sure that we can read each entry at a time as an index. But the problem is we have a linked list now, and we can't index into a linked list. There's nothing as linked list at I, right? It's just have to traverse it every time again, which is very inefficient. What we're going to do is we're going to use a sequential file. A sequential file is pretty much made for you to read through a sequential list, to read through a data structure that can be iterated through sequential. The 4 things from the starting code I gave you, the 4 things you have to implement are start, next, show, and stop. Start happens whenever you open the file, and then you want to start reading. You run start function once, only once. Next happens every time you move from one element to the other. Show happens every time you show an element. You want to print an element. You call the function show. Stop happens once at the end of your reading. So start happens, you call start before you start reading your list. You don't call it. The kernel is going to call for you your start function at the start of the list, next function in between the elements, stop function at the end of the list, and then show for each element is going to call show once. So the sequence is start, show, next, show, next, show, next, show, and so on and so on until you hit stop. Luckily, you don't have to implement any of those except for the show function. You can call API calls that are set up for you to do that. So let's start with our start function. You can start by using the sequential file has sequential list start, which allows you to just set everything up for you to read through a list. The first entry or the first parameter is the head of your list. Second parameter is POS. Okay, second parameter is an integer that's usually already provided to you as an offset. So that's all you have to do in the start function. Another thing that we'd like to see our output formatted in is we want to print a starting bracket in front of our list and a closing bracket at the end of our list. So what we're going to do in our start function, I'm just going to print a opening bracket to the file. So seek printf allows you to print something to the user without having to copy things to the user. So if you recall in our read function before, we used copy to user. You don't have to do that now. You can just use seek printf, and then finally the kernel will take care of copying things to the user with appropriate error checking and appropriate null termination. Okay. Next function, again, luckily we don't have to implement this. We can just call seek list next. The first parameter is going to be a void pointer that's already provided to you, called v. Second parameter is going to be the head of your list. That third parameter is going to be a pointer to the offset that you're reading from. So again, you don't have to worry about any of these. Just call the API call, and it will take care of things. Yeah.
Like, should it also be dereferenced, or like is that?
Yeah, in next, you don't dereference it because next is going to change it. Okay. In start, you have to dereference it because start only reads it. Okay. Yeah. Now we get to our show and stop. Let's do stop because there it's a little bit more useful or less tricky in a sense. So in stop, you don't have to do anything. The only thing you have to do is, for our case, we just want to close things off. So close our bracket. So we opened our bracket in start. We close our bracket in end or in stop. Yeah. All right. So show is how you actually format your elements. This is where you actually print the data to the user. So how do I know where I am actually? How do I know which entry in the list I am? We're going to use this void pointer. The nice thing about the kernel is that it's going to use this void pointer to give you access to the entry in the list that it's trying that you're trying to show. So the first thing we're going to do, we're going to create a list head pointer. Let's call it PTR. And we're just going to cast v into a list head pointer. And that's how the kernel tells you where you are in your list. It stores that pointer in your in the void pointer v. Next, we have to get the actual array element from it. And the way to do that, we call the function list entry. So list entry, you pass to it a list head, you pass to it the type of the struct of the element you want to read, the name of the element inside that structure, and you're done. That will return to you the element or the entry at that specific list entry. So in a sense, this gets you from here. List entry gets you from here to here. Okay, it allows you to jump from one to the other. Okay, so see if you have an errors here. Okay, we're good. So next up is I just want to print this element. So I'm just going to use, again, seek printf s and print element arrow value. Okay, that's the only thing I want to do here. And if everything is okay, I just return 0. All right. Now the only thing we want in our formatting as well is we want there is like a delimiter or a separator between our elements in the list. So one good place to do that is in the next function, I can just add a comma in between, and then it will print. It will do, since the sequence is head, show, next, show, next, show, next. It's going to print number, comma, number, comma, number, comma, number, comma, and there will be an extra comma at the end, but that's fine. Yeah. You can, but I'm just giving you another option here. Yeah, that's fine. You can just put the comma in here. That works pretty well, but I think this just helps us understand the sequence of things, how they are called. Okay. All right. So we have done our reading. We've done our writing. We don't need to do anything in initialization. Last thing we want to do is we want to clean things up before we leave, right? So instead of just deleting certain values, we're going to delete everything in our list. So again, we're going to need 2 pointers to array element, a temporary and an element. And then we're going to use the same syntax we used before. List for each entry safe. First element is our tmp head and list. So one thing to watch for, the family of functions that start with list for each, those are for loops. Okay, they're not function calls. Those are macros that define for loops. So you have to open a brace after it, close the brace after it. If you put a semicolon here, it's not going to do anything. It's just going to iterate and not print anything, and not do anything, not run your code. Right? So be careful about that. This is a macro, not a not a function call. So now I can just do list delete element arrow list, and I can free the element. So this is exactly the same thing as we did before, but now instead of only deleting certain elements, we're going to delete everything in our list. Questions? Okay, so let's try to compile this, see if we have any. I have an unused variable, which is fine. Let's try to test this piece of code. I think I have to remove the one I inserted before. Okay, so you insert your module. If we try to read from the procfs entry now, I think yours is called status, mine is called array, but that's just the same, just naming things. There's nothing in the list, so we're not gonna see anything in our list. Next, let's try to add something to the list. So let's try to add the number 10 to proc CSSE and array. So now if we try to read, we're gonna see our numbers starting to show up in the list. So let's add another 10 and maybe a 5 and a 100, and then try to read again, and we get our in-order list, 10, 10, 5, and 100. Now, if I tell my module to delete the number 10, what it's going to do is going to delete all entries that have the number 10 in them, and we end up with 5 and 100. Okay, and that's pretty much it. Now, if you remove your module project, you shouldn't get any segmentation faults here, right? Because we freed everything, we allocated, we don't have memory leaks, and we're in good shape. I think you don't see that. So the last thing I did is just remove the module from the list. Questions? Okay, so this is going to get you through all the way through everything in the first section. All of these, so you can start from here and keep going. You're only going to have to start adding slight modifications to this code as you go along, and then you start adding new features and new functionality. And I have recorded this meeting, so if you have, if you want to get back to it sometime, some other time, I'll post it on the class one.